In this talk, I'll be talking about Chapter 1 of PGM by Daphne Koller and Nir Friedman. In this book, in Chapter 1, they talk about the ability to reason for a computer is basically to take in information and act based on conclusions derived from that data. And the graphical model is basically a general framework to answer questions using a declarative representation. It's computer readable, it's manipulated by various algorithms, there's a separation of knowledge and reasoning, and there's clear semantics. In addition, it can handle uncertainty due to the partial observations of the worlds, because they're mostly noisy, there's an inability to observe, there's an inability to model, and there's an innate non-determinism. So there's a big problem between what is possible and what is probable. The deterministic specification of a complex system's behavior is hopefully modeled by a graphical model. The complex systems have multiple interrelated aspects, also known as random variables. These set of possible variables and their values is a design decision that's made by the graphical model. Then, instead of using a joint distribution, which is to reason probabilistically about the value of a random variable possibly given observations about a subset of others, you use a posterior distribution, making observations that xi takes a specified value given a value of other variables xj. And thus you can answer a broad range of interesting questions. So what are PGMs basically? They're a graph-based representation for compactly encoding a complex distribution over a high-dimensional space. They exploit structure and complex distributions efficiently. The nodes are the variables in the domain. The edges are the direct probabilistic interactions between the variables. It is essentially a skeleton for compactly representing a high-dimensional distribution, which is a representation of the set of interdependencies. So, what about representation, inference, and learning? How do you do that? Well, the advantage with a PGM is that you can write it down tractably using the graph-based notation. It's very transparent, and an expert can understand and evaluate it. Work can directly be done on the graph structure in orders of magnitude faster than manipulating the joint distribution explicitly, and you can reveal surprising connections between variables and provide novel insights about a domain. And finally, you can answer questions using distributions about the model of the world that's found in the PGM. That is Chapter 1 of PGM.